Okay, today is day 2 of rational functions. In my opinion, rational functions, you really ought to start talking about what a rational is. A rational number can be written as a fraction. Any rational number out there can be written as a fraction. So if I take like 2, is that a rational function? Yeah, because I can write it as a fraction. 2 over 1. Okay, thank you. How about if I had the number 2.8? Can that be written as a fraction? Yeah. 28 over 10 actually would work. Okay. Any rational number can be written as a fraction. So what on earth is something that can't be written as a fraction? Something that's irrational. Nope. 0 over 1. No, that's a fraction, and that's okay. 1 over 0. Good. And there's another thing. These are numbers that can't be written as a fraction. Pi. Okay, why can't you write pi? There you go, square root of 2. Because they are those decimals that go on forever and never repeat. All right, so fraction functions is all about rationals. Rationals is all about fractions. So if it's a rational function, it's a fraction function. And the parent of them all is this, which looks like this and has asymptotes here and there. Okay, does that ring a bell? Do you get that much? Okay, good. So do you get, if I put like a plus 2 on the bottom, that whole function is going to move somewhere? If it's in by the x, then it's on the inside. Do you remember that whole high-vo? Horizontal on inside. Vo meant vertical on outside. Okay, so if this is x plus 2 like that, that's inside by the x. It sometimes helps to say by the x. Inside by the x is where the horizontal stuff is. That's a horizontal move of plus 2. Remember, on the inside, you can't trust it. Seems like it's to the right 2. It's actually to the left 2. Okay, so I take all this stuff and move it left 2. The asymptote line, everything goes left 2. You with me so far? Now, do you get that I didn't have to move one of my asymptotes, but I did move the other? Think about that. This asymptote that was right here, do you get it still right there? That's the horizontal asymptote, didn't move a bit. But the vertical one moved. So the main thing for now, or for yesterday, was talking about your asymptotes and how to like take these things and move them just like simple little moves. All right, and where would the asymptotes be and stuff. All right, so if you look at these 3 slides, here's 3 graphs with horizontal asymptotes. I'm going to draw them in with a straight line maker because it just makes really nice clean asymptote lines. Would you please draw in the horizontal asymptotes? Some of these have vertical asymptotes too, but just draw in where the horizontal asymptotes have to be. I'm going to pause for a second while you do that. Okay, so the horizontal asymptotes go there and here and here. True or false? False. That last one's not a horizontal. That was a vertical that I put in there. How about here? Yes, those are the horizontal asymptotes. Okay, now, if we were looking for where that would be in the graph, do you get that the parent one here hasn't been shifted at all? This guy here, it hasn't been moved at all, okay? And its asymptote is at 0, okay? If we look at this one, it's been moved. Which way has it been moved? Up and to the left. So I'm going to write you an equation that could be this one. Y equals 1 over, how would I move it to the left? Plus, and let's say we move 2 to the left, okay, plus 2. And then how do I move it up? You could put parentheses around it, that wouldn't hurt anything, but you just have to mainly put it on the outside, plus, and let's say it moved up 2. Do you get now that's the equation for it? Okay, now here's what I'm going to tell you. When you see an equation like this, here's how you tell what the horizontal or vertical asymptotes are based on looking at the equation. Because at the picture, it's really easy. You just look for the dotted line that goes across. Where would the dotted line go? You guys all probably just got that right. So how would I do this one? If you look at this last one, you know what, let's say that it only moved up 1, just to make it clear which one was the up and which one was the left. Do you get the asymptote for this one was at 0, but then when the function got moved, it moved. You got a general rule for this? Oh, is there also a flip in that one? Oh, look at that. Yes, there is. There's also a left, right, or an up, down flip. That's one of the weird times where a negative, if you flip this kind, let's talk about that just in that, only that context. If you take this and you want to flip it, a reflection is going to either, whether you do an up, down, or a left, right reflect. This is a weird mind bender. Do you get if you take the black one and you reflect it, it becomes the blue one, and it does not matter if you go left, right, or up, down. It is in the same spot. Okay. So either way you reflect it, you end up with the blue one. So if you had a parent function that was the black one, I'll make a black equation for that. It was 1 over x. And then I want to flip it. I could throw in the negative here. I could throw in the negative here, which is like the same thing as putting it on top. Or I could throw the negative on the inside. And do you get that they really wouldn't matter in the, like, if I had a number there? Do you get in a fraction, it doesn't matter if the negative's on the top or on the bottom or in the front. It doesn't really matter. That's why the graph looks the same. Okay. So back to, you made a good point on this graph. There was also a reflection going on. All right, I want to go back to just kind of, this is the new stuff. Let me talk about what you should have learned yesterday. So if we have an equation like this, what is its domain and what are its vertical and horizontal? Actually, it didn't tell you horizontally, it told you vertical asymptotes. Domain and vertical asymptotes. Those are the two main things that you were supposed to get out of yesterday. And occasionally, you'd have a hole in the graph. Do those 3 words sound familiar? Okay, good. So let's see if you can tell on this equation, what's its domain? Well, you have to kind of know what it looks like. Do you get that this thing is a 1 over x fraction function, and therefore it kind of looks like this? Except it's been moved. Where has the function been moved? The left 3, very good. And then what? Up 5. Okay, so now it's like that. Now what's its domain? Well, do you get that this goes forever to the left and forever to the right, but there's one thing it can't be? -3. Do you get how you could have got that just by looking at the equation? -3 is the one thing it can't be. Because if you put the -3 in there, do you get how that the thing will have a 0 on the bottom of the denominator? All right, so the domain for this is everything. I like number lines for this. Everything works. That's how I always want you to start. Everything works except what? -3. So then you find any spot, I don't care where you put it, and you put a circle there and you say -3 is the only thing it can't be. Do you get how you could also write that? That's from -infinity to -3 and from -3 to infinity. That's number line versus, this is called interval notation. Do you understand that? Okay. The domain is everything that works in the function, and the only thing that won't work is the things that make it crash. What would make it crash? A -3 going in. Yes? Okay, if you wanted to write it with all reals, here's a third way you can write it. In fact, in Honors Pre-Calc, one of the units starts exactly this way. How can you write things like this? That is a double R. That stands for all real numbers. Instead of writing a R like this, it just has an extra bar. Double R, big R. That means all reals. That means all real numbers. Except x cannot be what? -3. -3. Okay. There's 3 ways to write that. That's your domain. Any of these 3 answers are all okay. I would accept any of those 3, unless on the test it says you must use a number line, or you must use interval notation, which would be the red one. Or if it says I don't think we'd ever say you had to do it that way, even though that is a good way to do it, that blue one. Okay, now the vertical asymptotes. The things that won't work. What are they again? In this case, what's the thing that won't work? There's only one thing, -3. The things that won't work are either asymptotes or they're holes in the graph. So I know that my list for my domain here had only one thing, -3. So that is either an asymptote or it's a hole. Did he show you yesterday where if you had something like this that was identical on the top and the bottom, that's the kind where it was a hole? Okay, if you didn't catch that before, let me tell you that now. If they have the identical thing on the top and the bottom, that's what makes a hole in the graph. As opposed to on this, do you get there's nothing like it on the top? Then that kind, the -3, is just an asymptote. So it's a vertical asymptote at x equals -3. And the hole for this one? None. There is no hole for this because we would need something on the top to cancel that thing on the bottom. All right, some of you are drifting off. Get back with me. Ready? Yes?
Would you either have a asymptote or a hole?
Yes, it can't be both. All right, so let me show you. Here's another one like it. Everybody, if you can factor it, you should. For right now, just factor it. We'll talk about, yes, generally if you can factor it, a lot of times there's a hole, but that doesn't always mean there's a hole. Really depends on the problem. Okay. Okay, if you can factor it, you should. So, Mr. M, factor that. On the bottom, it'd be x plus 5 and an x minus 5. Excellent. Do you notice then that something will cancel? That's what creates the hole. The one that does this is making a hole. Where will the hole be? The hole happens at the -5. Do you get the difference? Do you get how -5 is the thing that makes this one 0 and +5 is the one that makes that one 0? So there's two things, -5 and +5. Those two things both will crash the function. So in my domain, I would write all reals except x cannot be -5 and x cannot be 5. Raise your hand if you understand that part. Just be honest if you understand that. Okay. I need you to do it. I'm not going to focus on what you did before. I'm focusing on what you should know from now on. Yes? This makes a hole. Just hold on. Okay, let me just explain it a little further. I wasn't done yet. All I started with was, do you get that the domain is everything that works? And everything works except 5 and -5. Does that part make sense to you so far? Okay, good. So then I got two more things to know. The vertical asymptotes and the holes. The hole happens with this one. So these two things, this and this, either make a hole or they make an asymptote. You gotta fight it. You gotta stay awake. You must have stayed up too late last night. Be with me. Okay. So this vertical asymptote when there's a hole, I think I've said it like 5 times now, the hole is this one, and therefore the hole is at x equals -5. Now, I've actually heard math teachers argue this next point. If the hole is at -5, I remember a calculus teacher saying, well, this next thing you're about to do is kind of irrelevant. Because I'm trying to say where exactly is the hole, and they said, and this, I think this is a valid point, the hole is the absence of anything. There is nothing at the hole. That's kind of the point. So I really should be saying, where would the hole have been? Well, x is -5, comma, what's the y? All right, that's like a higher level question that I'll answer real quick, but isn't super important. So if this part's freaking you out, don't worry too much. If x equals -5 makes the hole, then the other thing, that was a hole. What's the other thing then? Yep, the vertical asymptote. Those two things are either asymptotes or holes. And the -5, that's a hole because there's one canceling another in the problem right here. Because of that, this number is a hole. No, it's not. There's no -5 to cancel it. Let me just show you what I mean. Just wait. What are the two things on this one that would crash my function? X equals -7, x equals 3. Which one of them creates the hole? Those two are the one that makes the hole. Since they make the hole is being created by the -7. This is the other option that crashes my function, and there's two ways to crash a function. You can either be a hole in the function, or you can be an asymptote. All right, so this has so many chances if you say things wrong. You got to be really careful how you say it, because you want to say a hole in a certain way. An asymptote, oh my gosh. And there's just so many chances for the teacher to mess up. All right, anyway, this one right here is a asymptote. And we're only talking so far about vertical asymptotes. All right, let's look at another one. Let's say I had this. X plus 14 over x minus 7 and x plus 6. What are the two things that would crash my function, Mr. H? 7 and -6. I'm going to say x equals 7 and x equals -6. Which one's the hole? There is no hole, because you can't cancel anything. And therefore, those two things, which had to either be holes or asymptotes, must be what? Asymptotes. Okay? So the vertical asymptotes are at those two things. Those are both asymptotes then. If there's nothing to cancel it, then it's an asymptote. Yes, sir? At the same spot? No. Can you have them in the same equation? Yes. So let me change this equation a little bit, and you'll see that one of these will stop being an asymptote and will become a hole. If I put an x plus 6 up here, do you get that creates this situation? Which means that one becomes the what? The hole, and the other one must still be asymptote. So x equals 7 is still the asymptote. And it's a vertical asymptote, by the way. And this one, x equals -6, is a hole. Now, let me get you a bit more advanced. Do you get, after those things canceled, what do they get replaced with when they get canceled? Are they zeros? No. They're ones. When things cancel, they become ones. Otherwise, things like this, think about it. If it was 6 over 6, we all know that's equal to 1, right? If you cancel them and make them into zeros, do you get that doesn't make any sense? Okay, when they get canceled, they get replaced by ones. All right, so back to this problem. If we get those two things canceled, they got replaced by 1s. My new function is 1 over x minus 7. That's my new function. It was y equals this. Now it's y equals that. After that stuff canceled, I have this function left. But it's got a hole at -6. What does that look like? Here's what a hole looks like on a graph. Say I have my graph like this, and there was a hole at like 3. Well, this is where 3 is. How do you have a hole in the graph? Instead of having a spot on the graph like normal, you have an empty spot in the graph. That's what a hole is. A hole is like the function just doesn't work at that one spot. It works everywhere else that it's supposed to work, just doesn't work there. That's different than not working at 0. Do you get how this function also has nothing at 0? It's got an asymptote line there. So that's the two ways things can fail. They can have an asymptote line like this line right here at x equals 0. Or at x equals 3, they can have a hole like that. There's two ways to fail. It's called, as you move up next year into pre-calc, they're called discontinuity. As opposed to continuous graphs, you can just draw nicely without ever lifting your pencil. That was a continuous graph. But if it's got spots that make you lift your pencil up, it's not continuous. So the discontinuities. Yes? No. Okay, I'll give you an example of that. Is there a hole in this one? Yep. What's its domain? And I'll give you a hint. It always starts with all reals. Or if you're making a number line, everything works except what? -5. X cannot be -5. Or if I was doing a number line, I'd say, here's -5, and it can't be -5. Are you with me so far? Then that -5, this x equals -5, then is either a hole or it's an asymptote. In this case, what is it? The hole. There's a hole at x equals 5. So where's the asymptote? There isn't one. Yes, it would be. Thank you. So there isn't an asymptote on this one, just a hole. So what would it look like? Well, remember when I said that these canceled, what did they get replaced by? 1s. So it's 1 over 1, which is equal to what? Do you know what the graph y equals 1 looks like? I hope you can picture that. Here's y equals 1. It just goes across like that. Except it's got a hole in it. Where's the hole? So I go over here to -5. 1, 2, 3, 4, 5. And at that spot right there, wish I had like a really small eraser, but there's an empty spot, and then the graph just keeps going. And that's a hole in a graph. The thing that makes it cancel like this makes a hole. All right, so one more. Say you had this. If you can factor it, you should. Then, once you got it factored, tell me its domain, which always starts with all reals except, and then tell me its vertical asymptotes, and if it's got any, maybe it doesn't have any, and its holes. Again, it might or might not have one. See if you can answer that question, and if you can, then we're caught up from yesterday. I got to teach you one more thing after that. Answering these? Okay. Try harder. Got a question or an answer? Okay. Ask it. Okay. First of all, if you had this, then it would not cancel each other. They would not cancel each other, and so therefore 3 is still a problem for this function because it would make the bottom 0. So your domain would be everything except 3 works. And then what is the 3? Is it a whole? No, because nothing canceled. So it must be a vertical asymptote. Very good. All right. So on this problem, did you factor it to x plus 1 and x plus 1? And on the bottom, x plus 1 and x minus 1? Did you notice that it factored that way? You're supposed to be good at factoring by now. We've practiced it. I understand if you miss one because I miss things all the time. But that's what you were supposed to do on that one. And do you get that those will cancel each other? Okay. So then the domain is all real numbers work except what can't x be? -1 and? Good. And those two things, this and this, are either asymptotes or wholes. Okay? So, because this canceled, which one of them is the whole? -1. X equals -1 creates a whole. Exactly where the whole is, I'm not going to bother with right now, but if it was at -1, do you get that's the x of it, and we don't know the y of where the whole was? But the kind of the point is there is nothing there, so we don't need to worry too much about the other coordinate of the whole. All right, then the other thing must be the vertical asymptote, which is what? X equals 1. There you go. Now, I'm going to pause for a second and look over the smartboard to see how we can condense this down. Okay, on this green slide, everybody find this. Find this green slide. Do you see it? Okay, good. Remember one of my favorite sayings? You can factor. You should. Do it. Factor this. I'll pause while you try that. Okay, so top gets factored. Bottom gets factored. Guy in the blue shirt. Give me something you factored. Top or bottom, I don't care. Okay. -3 would multiply by what and make 4? That's going to be tricky. 2 times 1 doesn't make 4 either. All right, I can tell you're not having a good day here, but I need you with me. Just do your best to follow this. All right, kid in the Minnesota shirt. I don't want to name names on the video, so go ahead.
X plus 4
X plus 4?
and x minus 1.
You are correct, sir, because the 4 times the -1 makes -4, so yay, we factored that part. And now, factor the bottom part. M. X plus 3, x minus 1, nice. Did you notice that there are 2 things that would crash my function? There are. And those 2 things are x equals 3 and x equals 1. So the domain is all real numbers except x cannot be 3 and x cannot be 1. And that's to be a -3. Sorry, I forgot the negative. Are you with me so far? Then those 2 things are either wholes or asymptotes. And remember, we were doing vertical asymptotes, right? So, did you notice that that one cancels that one and therefore creates a whole? All right, so the whole is at 1. Now, the vertical must be the other one then, which is x equals -3. Now, I did not tell you how to do horizontals yet. Now, I'm going to tell you that now. Okay, this is the new part. For horizontals, we get to meet a guy named Bob. Okay, and Bob tells you the horizontals, and I'll be saying that, and hopefully I'll remind you of something. And Bob is an outsider. Have you heard of the book The Outsiders? All right. So Bob is an outsider. Whatever is outside of your great big fraction is where the horizontal asymptote is. So the horizontal asymptotes are the y asymptotes. Notice the vertical asymptote was an x asymptote, right? There's another dumb thing I have kids do to remember this. The vertical are like the zertical asymptotes. You get how they're the x ones? Because so often at the end of the math problem on a test, we will say what was the vertical and what was the horizontal, and people put the wrong ones in the wrong blanks. Do you get how you might think the x equals were the verticals by accident or the horizontals by accident? So easy to get them confused. So I got two dumb names for these. Zertical, and take a wild guess what I'm going to call the other one. Horizontals. Very good. So that'll help you remember this is y equals something. Okay? Now remember, if it's a Bob, Bob is an outsider. And what's outside my fraction? Well, take a look at the original problem here. Is there anything that's like +4 or something outside the big fraction? Is there anything out there at all? No. So what is there out there? A 0, and therefore your equation is y equals 0. Now, why did I say he's an outsider? Because is there always a 0 on the outside? No. Sometimes there's a +5 on the outside. Do you get the whole graph has to move up 5 then? And so the asymptote line moves from 0 to 5. So whatever's on the outside right here will be your horizontal asymptote if it's a Bob. And what are you talking about Bob, Bob, Bob for? Because Bob stands for bigger on the bottom. Is this equation actually bigger on the bottom? Nope, it's not. How do you judge it? The degree. That's why we learned degree right before we got to this part. Do you get that both of these are degree 2? That means that this is not bigger on the bottom and it's not bigger on the top. It's same on both. Those are the three options. It's either a BOB, bigger on the bottom, a BOT, bigger on the top, or it's an SOB, which, yeah, you guys know there's another name for that. That could be a shortened acronym for silly old bore, maybe something like that. Anyway, so SOBs are going to make you sob to figure them out because they're the hardest ones. Bots, I got to get you to remember a dumb little saying. No bots. This is all about asymptotes. And if it's a bot, a bigger on the top, then there's no asymptotes. So, we should write these down. They're not going to write themselves down. Bot, there's no asymptotes if it's a bot. If it's bigger on the top, then it's going to be no asymptotes. So try to remember no bot. It's kind of like robots, and robots are going to take over the world soon, so you might as well get used to your robot overlords. Hopefully they keep us around to like oil them and stuff. All right. SOBs, same on both, like this one is. Notice, degree 2, same on both. If it's a SOB, then it's going to be y equals a ratio as opposed to Bob's, which were y equals the outside. A ratio of what, you say? A ratio of the lead coefficients. Do you get how there's a 1 and a 1 in front of these two? All right. In the ideal world, that's all I would have had to teach you today, is bigger on bottom, bigger on top, and same on both. But you came in a little confused on the other stuff, so we needed to spend some time on that. So now, I'm going to show you a few examples of bigger on bottom, which the answer will be y equals whatever's on the outside. Bigger on top, which was no bots. There's no asymptotes on the bot kind. And same on both, which means the degree is the same on the top and the bottom. And that's going to be a ratio of the lead coefficients. Yes? Yep. There's no horizontal, I should probably put an H in there, asymptotes. All right, so what was this one again? Bigger on bottom, bigger on top, or same on both? Same on both. So it's a ratio. Y equals what over what? What was the lead coefficients? So it's 1 over 1, so it's y equals 1. There's a horizontal asymptote at y equals 1. There's a vertical asymptote at x equals -3. And there was a hole at 1 because of this whole thing canceling. Don't mess around. You're going to have a hard enough time doing this. I'm glad you're awake. That's a good start. All right, so factor the top factor. Wait a minute. I can't. You don't know how to factor this yet. Okay, we're going to skip that one. Go to this one. Don't worry. You don't have any of those in your homework. Try this one, the yellow one. That one factors in the top. Freaks people out sometimes because it's not two parentheses, but it factors. Top factors, bottom factors. Then, domain is all reals except x cannot equal and x cannot equal is usually two things. And those two things are either holes or asymptotes. Then you ask yourself, is this a bob, a sob, or a bot? And Bob will tell us the answer. This one happens to be, is this a bob, sob, or a bot? Is it bigger on bottom, bigger on top, or same on both? It's a bob. It's bigger on the bottom. Why? Because it's got a degree 2 down here and only a degree 1 up there. If it's a bob, then it must be y equals the outside. What's on the outside?
3.
There's nothing on the outside.
Oh, not there.
There's nothing on the outside of this fraction. There's no like +6 on the outside. So therefore, if there's nothing out there, there's a 0 out there. And if it's a bob, it's y equals whatever's on the outside, in this case, 0. If it had been a sob, it would have been a ratio of the lead coefficients like 3 and 1. But it wasn't a sob because they weren't the same. And the last is, if it had been a bot, it would be a no bot. No asymptotes. Yes, sir? Nope. There can't. Then what you're thinking is two separate things being added. We wouldn't do that. It would not be a fraction function anymore. You'd have to actually get a common denominator to add them together. Way more complicated than we're going to get to. So it's either going to be one or the other. It's a bob, sob, or a bot. All right, last thing is, if you got this factored, let's get this done. The top should have been a 3 coming out of both. Raise your hand if you had that. Okay, good. The bottom should have been an x plus 3, and no, it isn't. X minus what? And, all right, I thought for a second we were going to have a hole, but it turns out we don't. Do you get why? Yeah, -3 and +3 aren't the same, so you cannot do that. So therefore, there is no hole. Therefore, x equals 3 is something, and it can't be a hole. X equals -5 is something, and it can't be a hole, because there's none, because nothing canceled. So what are those things, the 3 and the 5? Those are the verticals. Last but not least, the domain. All reals except x cannot be, what are the two things it can't be? 3 and -5. There we go. Good. They are similar, but if one of these two had been a hole, you get how it wouldn't be able to be a vertical asymptote and a hole? It's one or the other. So if one of these two had been a hole, then it would be knocked out and wouldn't be a vertical asymptote. So the way I like you to think of it is, these two are either asymptotes or they're holes. They're one or the other. And you look and see if there's any holes by things canceling, you know. If these had canceled, that would have made a hole. But there's no hole, therefore they're both asymptotes. So no, you can't just say they're always, these two things are always vertical asymptotes. They're either vertical asymptotes or they're holes. All right, now I'd like to actually start your homework. There's a section on there about writing equations for the graphs, and I've been around the block long enough to know that I'm not going to try to teach you that after all of what you've been through today. It's too much, so we'll skip those problems for now. We do have to learn them eventually, but we'll skip those in tonight's homework. Would you please try to find today's assignment, 9.7 worksheet B. And you don't have to do that rational functions quiz 1. We didn't have time for that because we were relearning yesterday's stuff. So 9.7 worksheet B. I'm going to pull it up right. Okay, so our worksheet looks like this. 9.7 worksheet B. Its title on the homework is just rational functions B. Okay? So Problems 1, 2, 3, 4, 5, those are all good. 6 and 7 are okay. I think we're just going to do, if we can do 1 through 7, that'll be plenty. Okay, that's it. Just 1 through 7. Ah, good point. And you may skip number 7 because we don't know how to factor this kind yet. We'll teach you that someday. Good, so it's only 1 through 6. Okay, how do you start them all? If you can factor it, you should. So let me actually start this with you. I know you've been sitting a long time, but hey, I'm offering to help you with your homework. You should take me up on it. So on number 1, there is no factoring. That makes it even simpler. Do you get that means that there's nothing that's going to cancel on the top and the bottom? And therefore there's no what? No whole. All we need is the horizontal asymptotes. And that's just the things that Bob tells us. Bigger on bottom, bigger on top, or same on both. What's this one? Same on both, because the degree is 1 in both cases. Degree 1, degree 1. If it's a sob, you're supposed to do y equals a ratio. A ratio of what, you say? 2 over 1. So what's 2 over 1 equal to? Y equals 2. Because it's the lead coefficients, the number in front of the thing that has the degree. 2 there, and there's a 1 on the bottom that you don't see, but there is a 1 there. All right, the next one. Is it bigger on top, bigger on bottom, or same on both? It's bigger on the bottom. What's the deal for Bob's? Who is Bob? Bob is an outsider, so it's y equals the outside. Is there anything on the outside? No, so therefore it's y equals 0. Good. If there had been a plus 7 there, do you get the answer? It would have been y equals plus 7, or just y equals 7. Okay, good. And then the last one on the top there, number 3. If you can factor it, you should. You factor it, and yes, it's bigger on the top, but we got to figure out, why do we have to factor it? Because, see, some people wouldn't have skipped the factoring thing, and you would have been disobeying my rule. If it cancels, it won't be an asymptote, will it? All right. But anyway, back to the if you can factor it, you should thing comes after we figure out horizontal is Bob. Bob is, this is not a Bob. What's this one? A bot. What's the deal on bots? No bots, and therefore there are no horizontal asymptotes. Now I still want to factor it to see if there's a hole. And is there a hole? Let me think. Nope. The 6 would be x plus 6 and x plus 1, and nothing canceled, so there was no hole. But it doesn't really matter too much because there's no horizontal asymptotes because it's a bot. No, because it's a, yeah, it's a bot. It's a bigger on top. All right, I know that was an intense day, but if you have to, you can always refer back to the video. And that's all I have for you for today.